this one, we call this function. Okay, still my function 2, the same one, right? Then x0, this is the initial values. Lower boundary, upper boundary without constraint. We know this is a constraint, right? These are something else. Then we want to get a result. Okay, probably I'm going to run this one first. Run optimization 2. Run optimization 2 here, right? We run it. Okay, so we want to see, okay, first x value, right? Want to see x. It's different, right? So it's different doesn't mean it's worse. We want to see, okay, f value. Okay, that is this value. Let's see, that is this value, right? So how about the previous one? Oh, this is negative. This is, this is a lot larger. We want to do the minimization, right? Apparently, the first one, is a better one. Okay. So what's the meaning of that? Okay. If you use a genetic algorithm, right, we don't need to assign initial value. The system will generate, I don't know exactly. In principle, you can check, what is the population size, how many generations, okay, all these parameters. In principle, it's possible, but if you want to save time, probably you say, I don't care, okay. Then what you can do is, okay, in this boundary, then when you do the genetic algorithm with the same operator function, then this is the optimal result. When you did this traditional optimization, this is the result. This is okay called the local optimal solution. Okay, local, the valley. This is a global one. So probably you can see, okay, if you use genetic algorithm, where is a global optimization problem, genetic algorithm is better. So when it's the traditional optimization problem, genetic algorithm, the yours is still good. But when you have a lot of peaks, some are higher, some are lower, then usually you have to use a global optimization, the method. Genetic algorithm, simulated annealing, we have, these two are most popular one. Okay. So, why this happen? Okay, because you assign the initial point, right? You assign here in the middle. Then it will go to here. If you can try, if you assign initial value, someone here, then it will convert here. If you assign this here, it will convert someone here. Okay, so so you can see GA is more reliable in terms, okay, global optimization. So what I'm going to say is GA global optimization is better than the traditional, the optimization if you have, okay, very strange shape, right? Okay. Genetic programming, I have to say, in MATLAB, we don't have any functions. Okay. I think, MATLAB, you're involved in this way. Okay, at the beginning, MATLAB has some functions. Okay, that means the many users are developed, for example, fuzzy neural and so on. Eventually, either, okay, MATLAB company consider, these functions are very common, they want to implement, or sometimes they just purchase these companies to buy the copyright. Eventually, to let this program to be one of these MATLAB toolboxes, and also, of course, compatible with all MATLAB functions. Okay, but right now, we have, some of the genetic programming, the tools. Okay, for example, if you go to this website, you can find this one, which is a very popular one, but I have to say, usually the genetic programming is our traditional one we talk about here. Okay. This one. You already talking about genetic programming, you read the books, you're going to talk about this one. Okay, I mean, we have libraries, examples in this way. We never consider we have a design, we have alternative design solutions, we have trees. Okay, we don't have such a thing. So that means, okay, for the design manufacturing, trees, genetic programming, is more useful. So that is, the last slide of lecture, and we still have 15 minutes. Probably, I'm going to give a review about examination. So I'm going over very quickly. You can stop me anytime if you consider, if you ask me a question, should this part be covered? Should not, that part will not be covered? That is very normal in North America. Sometimes, okay, I'm so busy, right? I want to get a good mark. That is okay. So when it's not required, first probably I'm not going to review today. Okay, I think that's absolutely fine, right? So we're going to do it this way. Tree, right? Problem, and probably you know, right? Okay, well, trees are good to solve certain kind of problems. First, the tree. Okay, if I ask you what is a tree, okay, I'll give one example of a tree. So this is a tree, right? So first you have root node. For each root node, we have subnodes. Subnode. For each subnode, we only have single parent node. For the parent node, we have one or multiple subnodes. So that is a tree. Okay. You don't need to give exact definition, leaf nodes. If you don't define, fine. But as long as you know this is a tree, that is good. This is a typical example. So how you can use a tree to model something, right? That is could be the question. Graph. So graph, we have nodes, we have arcs. Arcs are used to link all these nodes together. That is, okay. And also we have directed graph. We have directions, such as, the traffic system, one way. You can only move in one direction. Or sometimes we have undirected graph. We don't have directions, or the both directions. Okay, search. The search problem, you should know what is a depth first search. So for example, if you have tree, you know first we go to left side, okay, then that is called the depth first search. You don't need to know the algorithm. It's very complicated. You don't need to know, okay. But you should know what is the depth first search. So if you ask you, give one example to show depth first search. Okay, if you don't have any example, just use my example. That is fun. I know sometimes it's, I've used other examples. It could be wrong, right? Okay. Yeah. Then just use an example. Yeah. I think that is fun. You don't need to use it. Okay. No, you should understand this one, but you don't need to know, exactly this and so on. This is algorithm, right? Breadth first search, the similar one. So you know you search this in this way. It's called the breadth first search. Algorithm, no. This one, list, no. Base first search. Base first search, okay, that means it's still search, but each time, okay, you get the best one, okay, to generate subnodes. Okay, so if you know you have one evaluation, the function usually we call the heuristic function. Okay, either the shortest distance, okay, the minimum cost, maximum performance, it could be anything. Okay, that is, so then you pick up best to generate subnodes. Eventually, you get the final solution, right? So that is, the requirement for the first chapter. Second chapter. For the traditional one, I'm not going to ask questions. Traditional one. Fuzzy. Fuzzy set. Fuzzy sets are still sets, right? So I may ask you, so what is a fuzzy set? Can you give me one example? Okay, tall, short, okay, very good, okay, the less important, and also membership function, right? So okay, membership functions, you know, fuzzy set is associated or is modeled by fuzzy membership functions. We didn't introduce, sorry?
Exactly, if I want to define fuzzy sets or I want to understand, I know about the fuzzy.
Yeah.
So what should be the answer? Fuzzy set.
Okay, fuzzy set means, okay, yeah, if we say fuzzy set, right, usually the traditional set is crisp one, either yes or no. Fuzzy set, okay, then you already had to use, this membership function, right? Fuzzy set has to be associated with fuzzy membership function. They cannot be separate, right? So we say tall, then we can use this function to define tall. That is fuzzy set and definition. Okay. Membership functions, okay, you don't need to remember these exact names. So if you know, okay, we have this shape, okay, even you don't know the names, I think it's all right. But sometimes we call this name. Sometimes we just call different names. For example, Gaussian or Bell. Operations, Boolean operation, you don't need to know the traditional one. I'm not going to ask you the traditional set operations, but then you need to know this one, fuzzy set operations. Right? Okay. Complement. So if I gave this membership, right? It's the same, probably it's different. Complement. Then you are required to draw something. You know this relation. Then union. Okay, and intersection. So one is a maximum, one is a minimum. These two operators, these are fundamental fuzzy. The fuzzy arithmetic operations, this one is not required. I just want to show fuzzy, even you can use, the arithmetic operations, plus, minus, usually don't do it this way. Usually we have number, right? How? Okay, I just gave some concepts. Okay, this part is not required. Alpha card, is hard to remember. Okay. Fuzzy relations, this part is not required. Okay, you have AB, BC, or you want to get AB. We don't have a lot of applications here. Fuzzy logic. Fuzzy logic is important, but then to remember this one probably takes some time. Okay, for you to have better performance in terms of marks, I decided this part, these rules, the calculation procedure, whole procedure is not required. But then you have to know, if I say what is a fuzzy rule, right? So you should know fuzzy rule. Okay, this part is important. Okay, only say if you have these questions, you may not get a good mark. Okay, maximum, minimum, and so on, right? So one fuzzy rule. So if you know, okay, the speed is fast, okay, distance is short, then okay, if you know this fuzzy rule, and that be sufficient. Okay, and also in principle, This is called defalsification of center of gravity. That is also important, but I may not produce this equation. Okay, defalsification. We have different methods. This is one of the popular methods. Okay, but these fuzzy rules are required. Examples are not required. I'm not going to ask you to calculate this one. Okay, no, okay, because this is a short course. If it's regular one, yes, I'm going to ask students to do that. The short one, sometimes you are busy. Some students have to do TAs and so on. Okay, so I simplify, our task. Chapter 2. Then chapter 3. Neural. You don't need to remember this one. I think probably you should know this one. This is the most important, the neural network, right? So you have input, you have weighting factors, okay. You have this theta value. This theta you can call threshold, bias, okay. Sometimes we have different names. They are the same thing. Okay. And also we have this called transfer functions. Okay, even you don't know, exact name, hard limiter. Sometimes we call the hard limiter. Sometimes we call it something else. All right. So if you know, we have some transfer functions. That'd be fun. Transfer functions. We have more transfer functions. Okay. It is a typical one, a popular one. Usually this one, is the often used sigmoid. Okay, sigmoid in MATLAB is called log or something. Single layer. And if I ask you, can you draw the single layer neural network? Right? Yes, you should be able, to do it. Training not required. I think you should know, one is, the purpose single layer, right? Single layer, usually is used for the classification. You still have training, you have application, it's for the classification. That means if it's 2D problem, you can draw a line. 3D problem is a plane. 4D problem is, the high dimensional plane, okay, for the classification. And also, you should know the problem of single layer neural network. Single layer neural network, we don't have a lot of applications because it has limitation. So once it's a limitation, then probably you shall say is, you can only divide linearly. Or you can just say, very popular problem, XOR problem, you cannot solve it. So usually we explain this way, XOR problem, nonlinear problem, you cannot solve it. That is a bad thing. That is a limitation, right? Then multi-layer neural network, you should be able to, to know. So one is a multi-layer, single layer. So, you only have single layer of the nodes. You need a calculation. You have neural, right? You add the sum. You have transfer function. This one, you have here, then you need the sum transfer function. Here, you have, the transfer function. Here, you only have input node, right? So either consider this layer, or this layer, this layer. Usually, you have 2 layers. So this is not the 3 layers. This one just input, right? Okay. Then this part not required. Okay, this part not required. Not required, not required. Learning, okay. Supervised learning, we talk about supervised learning, right? So supervised learning is required. So if you say, what is supervised learning? You have correct data, you have neural network, then you train the neural network, you use neural network. And also Professor Sharma mentioned unsupervised learning. That means if you have so many animals, right? So then, I mean, you use, I mean, unsupervised learning, you can learn, oh, these, I mean, I know belong to one category, these belong to another category. These are dogs, these are cats, right? That is unsupervised learning for the classification, but we didn't talk about unsupervised learning, so this part is not covered. The last chapter, I'm going to go review again. Optimization, right? So first you should know this is optimization. Optimization objective is you want to find optimal decision variables or design variables. That is okay. Then you have to minimize or maximize something. This something is a function of these design variables. So basically, you want to get some values, some input values. Then you have this objective function. And also, I mean, this is a format. Then you have boundaries. You have two different types of constraints. These are required. Okay. Constraints, penalty functions, not required. So I'm not going to ask you, it's quite complicated. So this is one type of constraints. We have many, many other methods. So I just gave you some flavor. Traditional optimization search, this part is not required. Just give you some flavor. Okay. Then we just go to different directions, steps, distance, and so on to get this optimal result. This is traditional one. This part is required. What is the limitation of the traditional optimization problem? So if there is no limitation, we don't need the GA, right? The GA usually is considered part of AI. No, okay. So why we need the GA? It's complicated, right? Because global optimization problem. Okay. To solve global optimization problem, what you can do, you can use a GA. Evolution programming, you don't need to remember this one. Genetic algorithm, and what you need to know is, first, I mean, okay, you know, usually you have coding. Okay, coding, you have 0, 1. Sometimes we use 1, 2, 3. But in most cases, we use 0, 1. This coding is called chromosome. And also, this coding is a solution. This solution can be values of multiple variables. Okay, it can be multiple variables with some, I mean, Boolean variables. Okay, I mean, assignment of one person to a job or not. Use A machine, use a B machine, or don't use A machine. It can be this one. This is a solution or decision. Okay, that is a solution. It's called a chromosome. Then 3 operators. These are required because GA, the most important part is the 3 parameters. Okay, that's 3 operators. Okay. One is reproduction. You don't need to know this kind of stuff, right? You just know what is reproduction. You have better one, you produce more children in the next generation. You have poor one, you generate less reproduction. Crossover, probably you know this, right? So just get a tool, cut it somewhere, connect this one with this one, connect this one with this one with a small probability. Mutation, pick up one with small probability, pick one location with a probability, change this one from 0 to 1, from 1 to 0. Genetic programming, not required. Okay. Any question? I think it should be not a problem, right? Okay. Any questions about, the examination? Tomorrow at 10, right?
Maximum marks, what are the maximum marks?
Sorry?
Maximum marks.
Let me okay. I mean this examination is 70%, right? Then the project presentation and also report, that is 30%, right? Yeah, this is 70%. Yeah, I don't know exactly. I mean how it works in this university. Discussed with Professor Sharma. I mean long time ago. Then to decide this marking, then that is 70%. Yeah, but usually I mean these are simple questions. We have 2 hours. I think you can finish within 1 hour, but it does take time. You don't want to compete in that way, right? I finish 1 hour. I don't give an extra mark. Yes, if you stay, I mean okay. I mean I only give you a final mark, right? Any other questions? Okay. See you tomorrow. Okay. Thank you.